Some of the most often used instructions in PLC programming are comparator operations. In all of the previous PLC programs that we've worked with so far, we have mostly worked with bits. A bit has only two possible values of 1 or 0, true or false. And based on these limited values, you can easily demand the desired command for a PLC output. You don't need comparator operations when you're working with bits, but in reality, in almost all projects, you'll have variables with integer and decimal values which are greater than bit values. In this and next lessons, you're first going to become familiar with comparator operations, and then you're going to learn how to use these instructions in your PLC program through a few practical programming examples. The comparator operations are in the Basic Instructions window under the Comparator Operations folder. As you can see, there are 6 comparator operations listed here. The first one is the equal instruction. Using this instruction, you're able to compare two values with one another to determine if they are equal. These values can be variables or constants, or a combination of both. To do this, you can simply enter the first variable or constant in the upper section and the other into the lower section. For instance, I'll add MWO as a variable in the upper section and the constant value of 10 in the lower section. Then, for the output, I'm going to add a coil with the address of a PLC output. As you've learned in previous lessons, MWO includes byte numbers 0 and 1 from the bit memory environment in the system memory. This means that this word of the memory includes the first 16 bits of the memory bit space. Now, with the logic that I have here, when the value within this particular space of the memory is equal to 10, the instruction becomes true and allows the signal to pass, which energizes the output. Now, let's test this in the online mode. In the online mode, I'm going to add a bit memory in the simulator and change the address to MWO. Now, I can enter my desired value here. To be able to see the value of MWO in decimal format, I'll right-click here, and from the Modify menu and Display Format, I'll choose Decimal. Now, I'm going to enter 8 as a value for MWO, and hit the Enter key. As you see, since this value is not equal to 10, the instruction is not true. Now, I'll enter 10 and hit Enter again. This time, the instruction becomes true and lets the signal pass and energizes the output. The next comparator operation here is not equal. This instruction becomes true and lets the signal pass when the two compared values are not equal. The next one is greater or equal. This instruction becomes true when the upper value is greater than or equal to the lower value. The next instruction works exactly opposite of the previous one. Here, when the upper value is less than or equal to the lower value, the instruction becomes true. The next two instructions work the same as the previous two instructions, except they don't have the equal parameter. Okay, this was a brief introduction on comparator operations. But on each one of these instructions, when you click on this drop-down menu, there is a list of different data types that can be used. Because of a previous lesson on input, output, and bit memory addressing, you should be familiar with some of these data types listed, such as byte, word, and double word. In the next lesson, you're going to learn what each data type is and how you should use different data types in comparator operations.